Good day to all of you. Today we shall discuss on the topic addressing modes. This is studied in the subject computer organization by 4th semester AIML students in the course of Bachelor of Engineering under Computer Science and Allied branches. The content of discussion I have taken from the textbook Computer Organization 5th edition, the author being Karl Hamacher. My sincere acknowledgement and thanks to author Karl Hamacher. This topic comes in chapter 2 under the topic number 2.5. So this table 2.1 lists all addressing modes. The names of addressing modes being immediate, first one, second one register, third absolute, fourth indirect, fifth index, sixth base with index, seventh base with index and offset, eighth relative, ninth auto-increment and 10th auto-decrement addressing mode. Here EA means effective address. It is address of the operand. Computer is always given instructions for doing the work. In each instruction, what operation must be done is specified to the processor. So the operation may be arithmetic or logical, but this operation will be done on the operands. Where are the operands? The location of operand or the operand address is called as effective address. So the way of specifying the location of operand is called as addressing mode, and the operand address is called as effective address. If we take up the first one, immediate addressing mode, the operand is in the instruction only. So if the instruction is move hash 35 comma R2, so 35 is the operand. Hash indicates the number 35 itself is the operand. It is in the instruction only. Hence the name of addressing mode is immediate addressing mode. This 35 is copied to register R2. Next addressing mode is register addressing mode. So the operand is in a register. Suppose if we take the example move R1 comma R2, R1 is the source and R2 is the destination. From R1 to register R2, the content is copied. So here from R1 to R2, the data is copied. The operand is R11. It is in R1 register only. So the effective address is R1, that is the register number. Hence the name register addressing mode. So the effective address is R1 here. Next addressing mode is absolute addressing mode. So in this addressing mode, here instead of register, memory location name is taken. So here memory location name is LOC. In that what operand is there, that is transferred to register R2 because the destination mentioned is R2. Hence effective address is LOC, that is memory name here. Next, indirect addressing mode. So indirect addressing mode, the operand address is given in the register or memory. The first case, if you take in R1 register, operand address is given. If R1 is 1000, so operand address is 1000. So in memory where address is 1000, its content, that is the operand, that is transferred to R2. Here R2 is the destination. Hence effective address is 1000, which is given in R1 here. So this is indirect addressing mode specified using register. Next, indirect addressing mode specified using memory. So move bracket LOC comma R2. In LOC memory location 2000 is stored. That is the address of the memory. So in this memory location what content is there? That is the operand. So operand address is given in LOC memory and this operand is transferred to destination, that is R2. So the memory contains here the address. the address of the operand is specified indirectly through another memory. So the operand is in a memory, its address is specified in another memory location. Indirectly through this memory location, the operand is accessed. This is called as indirect addressing mode using memory, this one. The first case using register, the second case using memory. Either register or any other memory location can be used to hold the address of the location of the operand. Index addressing mode, in that base with index, x in bracket ri. Next comes index addressing mode. The index addressing mode, in that base with index, x in bracket ri. The operand address is generated by adding a constant value to the contents of a register. Here this is offset, this is index. So for example 20 in bracket r1. r1 is the index, 20 is the offset. r1 is having 1000. So the content of register is 1000, that is index. For that 20 offset is added. So 1020. So now this gives the operand address, effective address. In that memory location, what is there? That is transferred to R2 because R2 is the destination here. So effective address is 1020. Index addressing mode, in that base with index and offset, x in bracket ri comma rj. The operand address is generated by adding a constant value to the contents of register plus one more register is taken here. So x in bracket ri comma rj. For example 20 in bracket r1 comma r3 means r1 and r3 form the index. So r1 is having 1000, r3 is having 12, both are added. So 1012, for that this 20 is added. Then the final one is 1032, that is effective address, means in memory 1032 what is there, that is transferred to R2 because here in the instruction R2 is the destination. Relative addressing mode. The operand address is generated by adding a program counter register content to offset. This is similar to index addressing mode. Instead of register here PC is given. PC means program counter. It is a special register in the processor. It will be holding the address of always next instruction. If it is 2000 here, 2000 is added to what is X here. So 20 PC, this is 20. If this is 2000, both are added. Then 2020, that is the effective address. In memory location 2020, what operand is there, that is used for the processing. Auto-increment addressing mode. The operand address is generated by incrementing register content automatically. Here the register taken, for example R1, if it is having 3000, then bracket R1 plus means in R1 3000 is there, plus means it is incremented by one word size in bytes. If one word size is 32 bits, it is equal to 4 bytes. So by 4 it should be incremented, and when incremented 3000 becomes 3004. Hence effective address is 3004. In memory location what is there, so that is the operand and that is used for the further processing. The last addressing mode is auto-decrement mode. The operand address is generated by decrementing register content automatically. If register taken for example is R1, if it is having 3000, after R1 bracket minus means the R1 content is decremented by one word size, that is 4. So it will be 2996. Effective address is 2996. Then in memory location 2996, what operand is there, that is used for the further processing. That is the end of discussion addressing modes. I hope you understood. Thank you.